Hello everyone. I'm Sankalp Dayal and a final year student of Computer Science at VIT Vellore, and I solve some questions to help other people so that they can do good in the coding rounds and interviews and get placed very soon. So today we have this question, that is unique paths part 2, and yesterday we had solved unique paths part 1. So the difference is that in that we are given an m cross m and like two values, that is m and n, which is the dimension of the this grid, and we have to find the total number of unique paths. Now in this question it is the same as the previous one, and the only difference is that we can have obstacles in between. So if we have obstacles, we cannot step on that cell. So if we try to read this question, it is a robot is located at the top left corner of a m cross n grid. The robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid. Now if we have some obstacles are added to the grid, how many unique paths would be there? So we can have a basic DP approach in which like a matrix that we have created yesterday, that will be of the size of this input, and we will have the and each of this cell, that is dp of I comma j, dp of I and j. So it will store the total number of possible paths up to that position. So if we see here, the total number of paths will be the same as we did yesterday, that was dp of I minus 1 j plus dp of I minus dp of I and j minus 1. So it will be the same, and we have to do this only if the current value, that is in the obstacle grid, if the current value, that is the obstacle grid ij, if it is not equal to 1, then this will be, then we will store this value in dpij, and else it will be 0, that is dp of ij will be 0. Now this is because if we see the first example, we have 1 at 1 comma 1, and if we try to go there, so it is not possible because that is an obstacle. So the dp array will be having 0 at this position, and otherwise it will be the sum of the top value and the left value. So for example, if we see the next value, that is 0 at 1 comma 2, so it will be the sum of the previous value, that the sum of the value at the top and at the left. So it will be this will be 1, and this will become 0 because it is an obstacle. So this will also be 1. So now we can start coding for this. Now we will first check if m or n is less than 0, then we will simply return 0. Or if the first value is an obstacle, that is we can't start, so then also we will return 0. So we can add in this only, or obstacle grid of 0 0 is equal to 1, then also we will return 0. Now we will store one 2D matrix. So here m will be rows and n columns. M is length of this obstacle grid, and n is the length of the first row in this obstacle grid. So this is the number of rows and n is the number of columns. So dp will be initialized with 0. This is n columns and m rows. Now dp of 0 0 will be 1 because obstacle grid 0 0 is 1, as we have confirmed here, because if it will be 1 we will return 0. So now it is 0, so at start we will have this value as 1. And now for the first row and first column we will assign 1 to all of the values until this is 1. So if it will be 1, the dp value will be 0. So for row in range m, so it will be from 1 to m, because 0 0 we have already checked. So it will be 1 if the previous value, or if the current value, the dp of row minus 1 and 0. Okay, so this is for the first column. So dp of row 0 will be the previous value if the current value is not an obstacle, and if this is an obstacle, the current value, that is row comma 0, so this dp value will be 0. And we will do the same thing for the first row. And here we will check if the current value, that is 0 comma col, if it is not an obstacle we will assign the previous value in that column, and if it is an obstacle we will assign 0. Now this is for the first row and first column. For the other cases, now this dp of row and this col, so it will be the sum of the value above and on the left. And this is only possible if this is not equal to 1, else it will be 0. Now we have filled all the values in this dp matrix, and at the end we will have to return the last cell of this dp matrix. So it will be m minus 1 n minus 1. Okay, there was some variables issue. Okay, okay, and here call will also be from 1 to n. Okay, now we can submit this code. Okay, now for the time and space complexity for this question. If we see the time, now here we have three for loops. So for the first one, it is of the order of n. The second one is of the order of m, because it is from 1 to m. And for the third for loop, we can see that we have nested for loops. The outer one is from 1 to m, and the inner one is from 1 to n. So the time complexity for this nested for loop will be m into n. So the overall time complexity will also be mn. So the overall time complexity is mn. And if we see the space complexity, here these two are constant variables, and this is a 2D matrix which we are creating. So this is taking mn times space, and yeah, that's all variables that we have declared. So the overall space will also be mn. Okay, so that is all for this question. And like this was the DP approach that we had solved. And if we see the solution, we can see that they have also used DP. And okay, and what they are doing is they are manipulating the input array. So in our case, we had not changed the values of this input, so which is the constraint sometimes. But if we are allowed to change this input also, then we can do something like this. So instead of creating this another DP matrix, we can use this input only to change the values and update the values. So in this case the time will be same, but the space will be constant. So we can also see this solution. And if we don't have any solution for this question, we can check the discussion section. So again we can sort it using most by most votes, and we can open some of the top links. So I have opened the four links, like top four links. So this is a Java solution, and it is using a 1D in like 1D extra space. So in this way also we can solve this. And here we don't have any explanation, we just have the code. Now in this it is a C++ solution, and in this also they have used 1D or 2D vector, that is 2D space, which will be of mn size. So this is the same that we did. And if we open this another solution, here they have a good explanation, so we can follow this. And this is a very explanatory solution, so if we are not able to understand or solve this question, we can check out the solutions. And the last is a Python solution. So it is starting from mn times of space, and then it is optimizing to O1 space, and finally it is doing in place. That was the solution given. So in this way we can see the solutions, and we can understand like how the other people are solving this question. And then if we are not able to do it on our own, we can always take help from these solutions. And it is like recommended that don't see the solutions instantly, like if we are solving the questions now and if we are not able to solve it, so we can have 1 day break and we can again try it tomorrow. And if we are not able to solve even tomorrow, then we can see the solutions. Or if like hints are also sometimes given, so we can also see the hints if we are not able to solve this question. So that's all for this question, and thank you for watching the video. If you have watched the video till now, you can like, comment, share and subscribe the channel, and I'll be posting videos daily for solving the questions in this dynamic programming section. And I'll be sharing my experiences on Saturday, so just have a wait till then, and see you later. Bye.